In the previous video, we have discussed about percent by mass and percent by volume. In this video, we'll discuss more set or another set of concentration units. This time, it's based on moles. So we have the mole fraction, molarity, and molality. First, we have mole fraction. So here, we'll use the letter X to represent mole fraction. And then we'll use A for the solute. And then for the solvent, we'll use the letter B. So this one is read as the mole fraction of solute, mole fraction of solvent. So the mole fraction of solute is equal to the number of moles of the solute over the number of moles of the total solution. Meanwhile, for the mole fraction of solvent, it's equal to the number of moles of solvent over the number of moles of the total solution. So let's answer some problems related with this one. So first, we have here a solution made up of sucrose dissolved in water. So let's solve first the mole fraction of solute in this solution. So here, the mole fraction of solute again is equal to the number of moles of the solute over the number of moles of the total solution. So again, this one is the solute. We'll use the letter A for that. And then for solvent, we'll use the letter B. So first, we need the so first we need to get the number of moles of the solute, but here the given is the mass of the solute. So first we'll convert this one, the mass, into the number of moles. So here we have again 22 grams of sucrose, and then we'll convert this one into the number of moles. So we'll convert this one, so we put grams here to cancel this one later, and then convert this one to the number of moles of sucrose. So 1 mole of sucrose is equal to how many grams? So as you know, for this one, we need to calculate the molar mass of the compound. So let's calculate that one. Let's have another calculation. So we have carbon, hydrogen, and then oxygen. For this one, we need to determine the molar mass. So let's look at their individual mass. So for carbon, the mass of carbon, that is 12.01. So that's 12.01. Then here we have 12 carbons. The next we have for hydrogen, the mass of hydrogen is equal to 1.01. So 1.01. Then here we have 22 hydrogens. And then for oxygen, that's here. Let's round this one to 16.00. 16.00 times 11. Then we'll multiply this one. So that's 12.01. 12.01 times 12. That's equal to 144.12. 144.12. The next one is 1.01 times 22. 1.01 times 22. That's 22.22. And then for oxygen, that's 16.00 times 11. 16 times 11. That's 176. Then after, we'll add all the masses here. 144.12 plus 22.20. Again, 144.12 plus 22.22 plus 176. The overall mass is 342.34. 342.34. So this one is the molar mass of the compound. So 1 mole of C12H22O11 is equal to 342.34 grams. Then now we're ready to convert this one. So that's 22 divided by 342.34. 342.34. 22 divided by 342.34. That's 0.0643. 0.0643 moles of this compound over here. So 22 grams of sucrose is equal to 0.0643 moles. So we have identified the number of moles of the solute. Next, we need to identify the number of moles of the total solution, and then of course it's not here, so first we need to determine the number of moles of the solvent. So it's another set of calculations, so let's solve that one over here. Let's use this space over here. So again, we'll convert this one, the mass, into the number of moles. So it's a lengthy process. Grams of H2O convert to the mole of H2O. 1 mole of H2O is how many grams? Another set of calculations. So we have hydrogen, oxygen. For the masses, hydrogen, what? 1.01, 1.01 times 2 because it's H2O. Then for oxygen, that is 16.00 rounded. 16.0 times 1, that's 2.02. Then for this one, 16.00. Then add this one, 2.02 plus 16.00, 18.02. So this one is the molar mass of H2O. That is 18.02 grams. Then we are ready to solve this one. That is 75.3 divided by 75.3 divided by 18.02. The answer is 4.18. 4.18 moles of H2O. So 75.3 grams of H2O is equal to 4.18 moles. Now we're ready to determine the number of moles of the total solution over here. So that's 0.0643 plus 4.18. Let's solve that one. 0.0643 plus 4.18 is equal to 4.24. So that is 4.24. Okay, that's 4.24 moles. So I think everything we need is already solved. So let's solve now for the mole fraction of solute. Again, that's equal to the number of moles of solute, and that's 0.0643 over the number of moles of the total solution. That's equal to 4.24 moles. 4.24 moles. 4.24 moles. And then let's divide this one. That is 0.0643 divided by 4.24. The answer is 0.0152. 0.015. Right, that's 0.0152. So this one is the mole fraction of solute. Then for the mole fraction of solvent, that's the number of moles of the solvent over the number of moles of the total solution. For the number of moles of the solvent, it's also over here. That is 4.18 moles. 4.18 moles over the number of moles of the total solution. That's 4.24. 4.24 moles. And then let's solve this one. 4.18. 4.18 divided by 4.24, and this one is the answer, 0.986. 0.986. So this one is the mole fraction of solvent. Let's proceed to the next one. We have molarity. Molarity is simply the mole of solute over the volume of solution in liters. So let's go to another one. So here we have a benzene. It's dissolved in some solvent. So again, the molarity is equal to the number of moles of the solute over the volume of solution, the volume of the solution in liters. So here we need to find out the moles of solute, but here again it's given in grams. So first we need um to solve the number of moles from this one. So it's another conversion. So 2.5 grams of benzene to its number of moles. So let's use the space below. 2.5 grams, 2.5 grams of benzene. Convert this one to the number of moles. Benzene, then 1 mole of benzene. So 1 mole of benzene is equal to how many grams? That's another conversion of, let's determine the molar mass of benzene. That's carbon, then hydrogen. For carbon, that's 12.01. For hydrogen, that's 1.01. And then we have 6 over here. 6 carbons and then 6 hydrogen. Then here 12.01 times 6. 12.01 times 6. That's 72.06. 72.06. And then for hydrogen, 1.01 times 6. It's obviously 6.06. Then we add this one, 72.06 plus 6.06 is equal to 78.12. 78.12. So this one is the molar mass of benzene. Then we are ready to find out the number of moles. So that's 2.5 divided by 78.12. 2.5 divided by 78.12. 78.12 is equal to 0.032. 0.032 moles. So we have identified the equivalent number of moles of 2.5 grams of benzene. Again, that's 0. What's that? 0.032. 0.032. And then, so we have find out the moles of the solute. Next, we need to find out the volume of the solution. It's over here, but here it's in ml, so we need to convert this one to liters. And obviously 200 ml, that's equal to 0.2 liters. And now we're ready to calculate the molarity of the solution. The number of moles of solute, that's 0.032. 0.032 moles over the volume, which is 0.2 liters. Then simply divide, that is 0.032 divided by 2. The answer is 0.016. 0.016 mole per liter, or this one. So instead of mole per liter, we have a unit for this one. We use the capital letter M. This unit is read as molar. So the answer for this one is 0.016 molar. And then lastly, we have molality. Molality is the same, pero instead of the volume, we use the mass of the solvent in kilograms. So let's go and answer the last one. Let's erase this one here first. So it's another problem here. So wait, by the way, this one is not the, okay, let's have some correction here. This one is not the, this one is the mass of the solution. Oh, ba? Forgot. Oh yes, this one is the solvent. Okay, so here the for the formula, Again, molality is equal to the moles, to the number of moles of the solute over the mass of the solvent. So in this case, it's the solvent. So first we need the moles of the solute, but again here the problem is it's given in mass, so we need to convert this mass. 1.85 grams of NaCl. Then convert this one to the number of moles, so gram of NaCl is equal to the number of moles of NaCl. 1 mole of NaCl is how many grams? Let's not solve this one because it will take time. So if you solve this one individually, you may find out that 1 mole of NaCl is equal to 58.44 grams. 58.44 grams of NaCl. And then you solve for this one. 1.85 divided by 58.44. 58.44, that is 0.0316. 0.0316 mole. So this one is 0.0316 mole. So we have determined the moles of the solute. Next, we need the mass of the solvent. So it's grams, but of course, for the mass is dapat it must be in kilograms. So let's convert these grams into kilograms. Then if you solve for this one, 2,000 grams equal to 2 kilograms. So we are ready to solve for the molality. So that is the moles of solute. It's 0.0316 mole. And then over the mass, which is 2 kilograms. Again, the mass must be in kilograms. Then solve this one. 0.316. 0.0316 divided by 2. That is 0.0158. 0.0158 mole per kilogram, or we have another unit for molality. That's 0.0158. So we use this small m in italics. So this one is molal. So this is the unit for molality. So the answer here is 0.015 molal.